4:15, and we'll talk about that and see if there's anything interesting in that. Okay, we're here, and we have we're starting out. Okay, we have basically coming off an idle. There's our TPS right here. I got my foot into it slightly here, and I guess I made a request. I made a request to set the cruise control. I hit the set button here, not the resume button, so that's low. And so we got some action here. I'll blow it up. We got our motor doing its thing, and let's go to the next capture and see what happens. Okay, let's get our throttle in front so we can see it. Okay, burgundy is the TPS, and our black clutch is engaged. You can see that. And what's the condition of the switches? Okay. Alrighty. Okay, so basically we hit some more resume here. The resume accel was held down. The throttle started to go up. The resume accel was released. It found its speed and kind of continued there. And looked like we have a decel here. That most likely was because I'm holding my finger on the set decel switch. So you know that there's the action with the duty cycling, and we can see the throttle going down here. So that's our decel command that the actuator is doing, because I held my finger on the set decel switch continuously. I just didn't tap it once. Okay, so what do we got here? We got more action. There's the throttle. Now again, this is the cancel request. We see them at the same time, purple and gray. I apologize for the redundancy, because I tried to get as many captures as I could, just so for the sake of learning. But here we're high. Both those guys are high. That is the cancel request, and that will take us to. Okay. All right. I'm sorry. Okay, there's our cancel request. Our clutch disengaged, no cruise control action. We're in natural mode, or basically non-cruise control. We're at a normal natural idle here, and then something happened. I hit set again. Clutch got engaged, duty cycle action, and we're cruising, cruising down the road. Okay, right here we have some action. And what caused this one? Let's see. Okay, brake switch. Okay, they see the orange went high. Look at your schematic. Okay, I put my foot on the brake. Looks like it had a little bit of action to move that throttle in a certain position. You can see right there on the red duty cycle, it's doing something. But nonetheless, there's my foot on the brake. There's the clutch disengaging, and then we're basically back at an idle, and that's right there. Next frame, what happens? I take my foot off the brake, and I put my foot on the gas. Obviously, the throttle is going up, no cruise control. Right here, something happens. I hit set again. The clutch engaged, the actuator clutch engaged. We got some duty cycle action, blue, red, the green, the current's flowing, and we're in cruise control mode. Right here, something happened. It went away, and I want to see if I could figure out what caused that to go away. Possibly, I hit the brake switch. Okay, I hit the brake switch, and the clutch disengaged. It wasn't a result of any set switch. So basically, this went down. I hit the brake, a little delay there. I can't explain that, but nonetheless. Okay, right here I hit set. Okay, I hit the purple set. We're off the brake here. We get our cruise, our clutch engages, our pedal hump is there, and we're in cruise control mode. And our throttle is starting to, probably didn't really go anywhere, because immediately I stepped on the brake, the clutch disengaged, and the throttle never really had a chance to move anywhere. So we just can see the action reaction of the brake pedal being applied, the current stopping, flowing through the clutch actuator, and our TPS pretty much at a steady state. So let's go to the next one. I have my foot on the brake. I have a request. I hit set, but we don't get anything because my foot's on the brake, and that's a safety thing. As you can see, our gray guy is low. I hit set, but with my foot on the brake, we don't get cruise control. Right here, my foot is off the brake. I hit set, and we are not engaged. There must have been something action here. Maybe the main switch was off, but right here I hit set, and we engage the clutch at the actuator. We have duty cycle action, and that's going to control the throttle. Let's go to the next frame. Right now we got something happening. We have, again, there's that resume acceleration command right here. We're high here. We can see the throttle moving up, 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 up. Our clutch is engaged, and we got a duty cycle action. Right here is where I take my hand off the resume accel switch right here. And how's our purple guy? Okay, that's still low. It looks like, again, this is a cancel request. You see they're both high. Throttle moving down, clutch disengaged. Okay, abruptly disengaged, and we are out of cruise control, and I'm just kind of coming to a halt. I hit the brake pedal here, and I stop the vehicle. How are we doing? Our next capture right here is I'm gonna do a little change-a-roo with the leads, and I will explain what I'm doing. Keep an eye on your schematic. At 3:37, I changed out 2 of the leads. I took the leads off the set and the resume terminals at the cruise control module, and I traded them out where I got vehicle speed. As you can look on your schematic, look at the vehicle speed line between the PCM and the cruise control actuator and the AT communication line. So gray is going to be a duty, you don't see it there, but that's a duty cycle that will start. That's an AT comm line between the PCM and the cruise control actuator. This purple is vehicle speed. This is basically frequency. And you'll see that is hertz. That will change as the vehicle speed changes. So let me go to the first capture, and we're not going to see any set resume stuff because we're not on those channels, but we'll deduce what's happening. Basically, I'm on the brake here, and you can see us. I step off the brake. The vehicle starts to move. You see the frequency starting to go up. I probably come off a stop sign, and the vehicle's starting to pick up speed. I'm into the throttle. We don't have any engagement. I'm starting to climb. My foot's going into the throttle a little more. What's the next capture look like? Okay, right here we got engagement. Something happened right around here. You can see the clutch actuator clutch engage in black. Now we don't have our set and our resume switch to look at, so I probably hit set right around here. And we can look at our gray guy, like our AT communication. Now that the PCM and the cruise control actuator are starting to talk, there's communication being shared. That's paramount because the transmission is still shifting, and cruise and where the throttle is really important. So one's got to know what's happening with the other. So there's our throttle. We're here at a certain angle, and we come down because we had cruise control actuation. We're still engaged. Let's go back to our next slide. We can see something happening here. We're kind of changing directions here. Okay, we went from the throttle motor was moving. Let me stretch the TPS so you can see it a little better. That's the TPS, and you can see a pretty drastic change. We're up here, and then our throttle motor changes directions, obviously by the red being high and the blue being low, and the current going the opposite direction. That's really the key to understand this. It's very similar to drive-by-wire. As I said earlier, it's like a prerequisite for drive-by-wire. So there you can see our throttle going down. We got duty cycle communication because the cruise control actuator and the PCM have to know what's going on. They have to share information. That is duty cycle right there. I'm going to say about 25. I'd say about 25% duty cycle. It's low. It's high 25% of the time. Anyway, let's move on. Something happened here. Okay, let's look what happened here. Looks like we had some. Looks like I stepped on the brake. As you can see in orange, that is the brake pedal. We're high here. Safety. We immediately open the clutch. The throttle comes down abruptly like it's supposed to. That's a safety feature. And the duty cycle between the PCM and the cruise control actuator stops. You can see we got duty cycle, but all of a sudden the communication lapses, and you can see the flat line there. Vehicle speed is the same. I will make a math channel later that'll be easier to see. And basically we're in non-cruise control mode when we're cruising down the road. Next slide. We are in cruise control here, and let's see what happens. Right about here, something abruptly changed. Again, I stepped on the brake pedal, our throttle went down, our clutch disengaged. I'm kind of speaking, starting to echo here, I apologize. And here we go. And basically we're in non-cruise control mode, and I'm working the throttle and up and down here. We're not engaged with our clutch. And now we got engagement. Something happened here. Most likely I actuated it. We got duty cycle. We got an engaged clutch at the actuator. We got motor control with the throttle motor, the cruise control motor, current going one way or the other. And we got vehicle speed in purple. You can see our speed. That is right there. That is frequency in purple. And we are engaged there. And there's our TPS. It went to a certain position right here. It's kind of going down because the cruise control goes both ways now. It can move the throttle either acceleration or deceleration with duty cycle precision control. Anyway, next capture. What's happening here? Looks like a bunch of I'm probably toggling on something. I could be toggling on the set switch. We can see it's changing. Red is high, blue is low, green is high, red is low. Current going opposite directions. Our throttle moving up. Our actuator clutch is engaged. So right here, what's the next thing? Something a little more recognizable here. Again on the brake pedal. No, not on the brake pedal. I must have shut it off here. Something might have happened. I probably hit the main switch. I know it wasn't the brake pedal, but main switch will abruptly shut the cruise control down. You can see the current stop flowing through the actuator solenoid. You can see the throttle abruptly kind of tailed downward, and you can see it going in that direction. The next one, let's go to the next capture. I'm stepping on the brake, probably coming to the end of the road test. There's charging system dip a little. Vehicle speed, and then basically that's the end of that one. Our next capture is at 343. I'll tell you what's going on once I see it, I recognize it. And let's take a look. Okay, we'll go back to the beginning at 343. Basically, that's me on the brake, off the brake. There is no cruise control. That is vehicle speed. The vehicle's picking up speed there. Let's go to the next capture. Throttle going up. No, we kind of have a little gap here. I may move on to the third capture to see if we see. Obviously, we have engagement here. Let's take a look. We see current going through the clutch. Throttle's going up. Definitely communication between the PCM and the cruise control actuator via duty cycle. You can see where the throttle is. We can see all this action I've been talking about for the last 40 minutes between duty cycle control. Vehicle speed is in purple. Bring that to the front, or I'll bring that here. Obviously that is frequency. It's hard to see that changing. You will on the next capture. I will show you something called a math channel. It's very powerful. There's our duty cycle between the PCM and the cruise control actuator. I'll move on past these captures. It's basically right here we had an abrupt shutdown, most likely due to, let's take a look, and that's me on the brake pedal. See, I step on the brake pedal, current stopped flowing, throttle went down. Vehicle speed is still kind of cruising, and we're still moving. We got no engagement here from the cruise control actuator, no duty cycle control, and right now I'm stepping on the brake. Vehicle's starting to slow down. You can see that it's opening up there. Throttle is moving, but slightly going up. I'm on the brake, and looks like we got re-engagement again on the cruise. You can see the current going up. We're duty cycle action, and the throttle is actually moving. The cruise control actuator is moving the throttle down. Because remember, it goes both ways. It can either move the throttle up or down. There is our duty cycle command between the PCM and the actuator. Honda calls that automatic transmission communication. And as we come to the end of this capture, um, the car's decelerating. There is our disengagement, because I stepped on the brake there, right there. Orange went high, you can see it here, okay? And the next capture most likely is, right, stepping on the brake, car coming to a halt. Here we go again. I'm gonna get to a four channel capture, and I'll talk about something else that's really important. This is 9:52 on the 16th, and I'm going to talk about this capture because it's kind of interesting. Okay, now we're on a different scope. We're on a 4-channel scope, and basically black is going to be the PCM to cruise control actuator duty cycle. Blue is the current ramp of the motor. We're only going to look at current so we can determine which way it's going. We're not looking at voltage changes via duty cycle, because 3 is vehicle speed, that is our frequency, and red is the TPS. So we basically have 4 items here, and it makes it a lot easier. Let me filter the green guy, and I will create a math channel, and then we'll see where the speed of the vehicle is. I'll filter the red guy, our TPS, because it'll be a lot smoother. And let's stretch it a little bit so we can get some definition. So there's our throttle, okay? And there's our duty cycle action via current. There's our transmission communication via duty cycle. I will create a math channel so we can see the vehicle speed a lot easier. So I will go to math channels, and I will go to frequency C. It's gonna be in magenta. That's our color we picked. And now we're gonna see, okay, you can see the magenta, that is vehicle speed, right? It's kind of like a scan tool graph. It's a process vehicle slightly going up here. We're plateauing here. That's where the throttle is. So let's go back to the beginning and kind of look at this one. It's got 24 frames. It's kind of interesting. You can see there's me on the throttle. There's no cruise control action because there's no current on blue. The vehicle speed is picking up, and the magenta, you can see the frequency get thicker. We can see the magenta go up, which explains it. It's all corroborating. Higher frequency, higher vehicle speed. Our next channel is, let's see, we got more speed. Okay, we're up. Our throttle is going up. We're plateauing here. We got a little action on the throttle. Up, a little more action on the throttle. And the vehicle speed's is ascending. Now we got cruise control engagement. We can see current flowing through the motor, the actuator. And now we got our duty cycle communication between the PCM and the cruise control actuator. And let's kind of see what happens. Okay, we got action, and we could see current going down here. The throttle is going up. Okay, the speed is starting to change slowly. You can see that. Right here, we took a change here where the throttle went down. See the throttle down. It's descending, sort of stepping slowly. That's current went the other way. It moved the throttle motor the other way, and our speed is going up. That seems counterintuitive, but nonetheless, just we'll have to go with it. Obviously, here we go. The throttle going up, and the speed going up. Nonetheless, let's go to the next frame. Maybe it'll make more sense. Okay, it does make more sense here. Our cruise control most likely became disengaged here. Our throttle went down here. We stopped duty cycling, and the vehicle started to slow down. Right here, the vehicle is increasing in speed. The throttle is going up. Let's keep going, and we can see the throttle going down, the vehicle speed going down, and right here we see a pretty wild swing here. This is the vehicle going down. You can see the frequency starting to open up. Then all of a sudden the vehicle speed picks up and the throttle picks up. That makes a lot of sense. It's kind of running in sync with one another. And anyway, what we got here, we got a pretty good swing on speed right here. We go up, vehicle speed going up, throttle is sort of plateauing. Don't forget, this is transmission information here, so shifting is a variable. Right here we have cruise control disengagement, throttle going down, down, down. The next capture is cruise control is deactivated. It looks like we're kind of, well, I guess we're kind of ascending a little bit in speed. And here we go. We've kind of plateaued on our speed. We've got a throttle. It's pretty level. Next one, we see where the vehicle is coming down, 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 down. You can see the speed going down. We're probably decelerating there. And then definitely more the speed, and then we actually come to a stop right here. There's no more frequency right here. The vehicle is actually standing still right here. There's no rotation of anything of on the powertrain. So basically we're at a standstill, and we got a little bit of movement there, a little more. Okay, now we got something picks up, the throttle picks up. Cruise control is not engaged. These vehicles kind of going at a pretty good clip. The throttle's moving up. Throttle moves up more. What happens here? We got some cruise control engagement. See our tranny communication right here, engagement. It's moving the throttle here. Right here, we got more engagement. The throttle going up, and right here, throttle going down. Cruise control action. No cruise control action, and basically we see at a pretty good speed here, and then we decel, the throttle coming down, and right here we got some cruise control action. Throttle is staying at one spot, and now the vehicle's slowing down right here. You can see that. That's our frequency. That is getting lesser and lesser, the cycles per second, and basically that's me on the throttle with no cruise control, and we got the vehicle, actually the vehicle's increasing with the throttle, and then the vehicle is slowing down as the throttle comes down. So anyway, I got one more, and that should be the finale. If I lose you, I'll try to make a part two, but I think I could do this in one shot. It is at 10:37. I will go back. We will go back to 8 channels. This is the finale. Let's go back to the original. Okay, we're on frame 1. We're back at 8 channels, but we are similar as we were on 4. Our gray channel is our duty cycle between the PCM and the cruise control actuator, and this time our purple channel is the speed, is the vehicle speed. Right, it's right here. That's frequency. That is vehicle speed. That is duty cycle communication. The vehicle's starting to pick up speed here. Our throttle is right here. That is burgundy right now. Now there's our throttle. It's kind of closing a little bit. Let's go to the next capture. Right here we can see our black engagement of our clutch. We can see I'm on the resume button again. We got change, we got throttle movement. Let's keep going. I'm on the brake again. Everything comes down, the throttle comes down, the thing gets disengaged, and I'll go down the line to where anything is interesting. I'm just on the throttle myself, no cruise control, and I'm on the brake, no cruise control, vehicle probably slowing down. Vehicle is stationary. I could definitely determine that. There's no frequency on purple, so basically the vehicle is halted right here. See if I pick up speed, anything happens. I'm probably revving it. Right now we got some action. Okay, purple is I might have lost that signal. I'd have to pretty much infer that I lost the speed signal. That is that, and there is our TPS. We should hit on the brake, and let's right now I'm on the brake. I just want to go back to the beginning of this and see. Okay, that's our speed. I know it's a long video. Thanks for watching. Again, this is basically electronic cruise control. It's sort of a prerequisite to drive-by-wire. As cars progressed, the drive-by-wire took total command of this. There is no physical throttle cable between the driver's right foot and the throttle, and this is all incorporated into the PCM. Anyway, hope you enjoyed the video, and signing off, and all the best. Take care.